Hello there, and in today's video we're going to get into the distance formula. It's a pretty straightforward concept, and we're going to go pretty quickly, so let's get started. Alright, so the only term to define here is the distance formula, which is a rearrangement of the Pythagorean theorem, and it looks like this. The distance is between A and B is defined as the square root of x squared minus x1 squared and y2 minus y1 squared. You'd plug in your numbers and you would solve what you get left over. It's actually really straightforward. Let's try it out on the next slide. All right, in the first of our three examples today, I have the distance formula being applied to m and n. These are two coordinates, and I would need to know how far apart they are from each other. So when I rewrite my distance formula from memory, I remember that it should be, wait, it's not adding, it's subtracting inside the parentheses and adding in between the parentheses. I am going to plug in my, I'm going to call m my first point, and I'm going to call n my point 2, my second point. Okay, and then I need to plug in my values. So where is my x2? My x2 should be here at -8. So I plug that in, and then the subtraction symbol, and then x1. Well, where is my x1? Fill in some of these other blanks while you're finding x1. And it should be here at -3. So -8 minus -3. I do need to keep these squared on that, so I will recreate that. Now my y2. Where's my y2? It's here at -11. Take away my y1 value. I still have the subtracted minus y1, which is my leftover value, 5 here. So then I square whatever is left of that. So I leave the square root so I can figure out what these values are. -8, take away -3. I'm going to be left with -5 here. I'm going to keep the parentheses on this because I'm about to square it. And I do need to square the negative with that value. Same thing will happen over here. I'll have -11 minus 5. That is a total of -16. And I also need to square that, which is 256. These are being added together, and I'm square rooting this total. So I'm going to get the total first, 256 plus 25, and I'm going to get the square root of 281. I don't know the square root of 281 offhand. Oh, that's why. It's irrational. It's a very curious decimal. It doesn't say to round here, so I am tempted to leave that as just the square root of 281. All right, so my calculator is helping me out here. It says that the square root of 281 is 16.763. It keeps going. I'm actually going to write out to 05, and then I'm going to put a ... to indicate that that number goes on forever. And we're done. That's the end of this example. Let's move on to the next one. Now, here in our second example, we can see the convenience of having a formula to do the distances with. It's so much nicer to deal with this kind of problem when you have just an equation that can calculate everything out for you, and a calculator that can help you with getting the numbers right. So I'm going to take a moment here and note that my B coordinate will be my 0.1, and my C coordinate will be 0.2. And again, I'm being asked to determine the distance between these 2 points. So I'm using my distance formula. D equals the square root of x2 minus x1 quantity squared, and y2 minus y1 quantity squared. So I need to find my x2, which is here in my C point of -1.8. So negative 1.8. Just plugging all the values in, just like I did in the last slide. My x1 is 18.5. And looking at that, that's kind of annoying to deal with the decimals and the squared value. So I will be getting my calculator out here in a moment. y2, meanwhile, is on my second point, my y value of 5.8. And y1 is negative 3.2. So we have ourselves a double negative situation in this example as well, where I have 5.8 minus negative 3.2. So I'm going to get my calculator out, particularly for the squared values here. I don't know what this, I know that this will come out to something like 20.3 or negative 20.3. But I am not sure what that squared value is going to come out to. So we're going to take that number, add them together, and square it. I get 412.09. That's the first number I get of just doing the subtraction and squaring. Next, I have the 5.8, take away a negative 3.2, and then squaring it. I had 9 actually here, so 9 squared is 81. Whoop. All right, so now I can add those together. I'll get the square root of 492.09. I need to know what times itself is that number. What times itself? Oh, calculator in my hands. What is the square root of 492.09? All right, so I get something approximately. I am going to round this because I only need so many decimal points. We get 22.18310. So I am rounding there. Oh, but I need to round to the nearest tenth. I actually have to round more. I only need one decimal point. So I'm going to leave my final answer as a distance of 22 point, well, so 1, the 8 will round it up. So I'm going to go ahead and call this 22.2. Kind of an interesting answer. That value, distance equaling 22.2, we have finished the problem. We've given the distance between the 2 points, rounded to the nearest tenth. Let's move on to the next one. For our third and final example of this particular set of notes, we get a word problem. Elizabeth drives from home to the store to get groceries. She drove 6 blocks east, then turned right and drove 5 blocks. Finally, she turned left and drove 2 additional blocks to reach the store. How far is it from Elizabeth's house to the store? As the crow flies. Well, that phrase there at the last end, as the crow flies, let's address that right away. First off, this is a typical reference to a straight line distance between two things. Distance. We're going to be finding distance in this problem. So let's put her house in the center. It's pretty easy to just start there. I'm going to put H for house, and then maybe I'll put G for groceries. So she's going to drive 6 blocks east. I know I've got this labeled X and Y, but we can also use the cardinal directions north, east, south, and west. So east would imply to the right. So 6 blocks east. So we'll draw that out to 6. I guess we're going to assume this is like New York City or something where the blocks are generally the same size. Then turn, or maybe Savannah, then turned right. Okay, well, if you're going this way and you turn right, you would be turning, I suppose this one would be turning down clockwise. So turning down 5 blocks, 1, 2, 3, 4, 5. Finally, she turned left. Now this is something where people might instinctively turn left this way. But if you're already going downwards, then going forwards would be straight down. Turning left would be this way. So she goes 2 additional blocks to reach the store. So I'm going to put the G for groceries. G, there we go. G for groceries at that coordinate. That is 8, 5, or 8, negative 5. So as the crow flies is again representing distance. So we need to just draw that distance there. And we need to know this length between her house and the grocery store. Say if she has to walk back or something. So, yeah, I guess I've made this problem a little bit more convenient just because I declared her house to be the coordinate 0, 0. But I am still going to use the distance formula to sort the rest of this problem out, as the grocery store is located at 8 over on the x-axis and -5 on the y-axis. All right, time to apply the distance formula and plug in our values. So my x2 at the end of this problem, the x2 is 8, and my x1, I am using the subtraction sign between these two, subtracted from 0. Well, that's going to be easy. That'll just be 8 minus 0 and then squared. That'll come out to 64 here in a moment. Adding in the y2, which is -5. Take away the y1, which also is 0. And then square that. All right, so the subtraction becomes really easy here. I just have 8 minus 0, which is 8, and squared is 64. And then I have -5 minus 0, which is -5. But then -5 times itself is a double negative, so it turns into a positive 25 that we are adding. So 64 and 25 is 89, so I need the square root of 89. I'm going to get my calculator out again. Square root of 89 is 9.43398. I feel compelled to round this one, although I'm not sure what to. It doesn't say. So perhaps I'll leave it at 9.434. That would be the rounded value to the nearest thousandth. I'm comfortable keeping that, considering that we're given all of our distances in 1 block increments. So maybe I should round this to the nearest whole block. If I were to do that, I'd say 9 blocks. I would want a little bit more information in this problem. If I was truly testing with this question, I would have to include a little bit more information, perhaps saying rounded to the nearest whole block, or rounded to the nearest hundredth of a block. But because I'm not given any of that information, I'm going to be more specific, just because I'd rather have more information than not enough. And that's it. That's my answer. I'm leaving it at 9.434 blocks as a distance between the house and the grocery store. So, to sum up what we're dealing with in this set of notes, it's really just a matter of plug and solve. See, you get your coordinates, you write in the formula, you plug the values that you have into the formula, and then you solve the final value. That's as far as we've got for the distance formula today. I hope you guys were able to make sense of that, and I'll see you in the next one. Bye!